Hi, I'm Steve Bjork, and today I'm going to talk to you about the most recent LambdaSharp challenge. We do this every month. We get together and we do a serverless challenge, which allows us to explore and experiment with different AWS technologies. So we got more fluid in them. And this month, our challenge was to build a bookmarking service. Basically what you would expect it to be, you can submit URLs, it remembers them, it provides a shortened version of the URL, and then it also generates a preview link with the metadata of the page it is pointing to. The challenge itself is located on our LambdaSharp GitHub repository under Bookmarks. And every challenge we do is always structured in different levels, and that is so that beginners as well as more advanced developers can always have a sense of achievement. And for this challenge, we started off with generating a shortened URL, then retrieving the metadata for the page it is pointing to and storing that, being able to generate a preview of the page using the metadata, and then also redirection as well as an ability to see which categories have been indexed and retrieve URLs by category. So this is the architecture. It's a serverless application. It's all deployed with, of course, the LambdaSharp tool. There's a REST API that is used for invoking a Lambda function. Data is stored in a DynamoDB table. When records get inserted here, which are new URLs with their shortened identifier, another function gets triggered that is used for then reaching out to that page and retrieving the Open Graph metadata, which contains things like the title, the description, the image, and augmenting the record in DynamoDB table so that subsequent calls to the preview API can then render a richer representation. So let's take a look at the source code. So I went ahead and I already deployed it using the LambdaSharp tool. It took about 2 minutes to deploy, as you can see down here. And okay, I'm just going to collapse that. It's quite a single deployment. There are multiple endpoints. Each of them have generated models for validation in API Gateway, and I'll talk about that in just a second. Okay, so here's our YAML file, which represents our LambdaSharp module for this challenge. The bookmark table was given, so the definition is very straightforward. We simply say that we want this table to be visible to all Lambda functions in our module. We initialize the table to be paid by request, so it's extremely cost effective. We also indicate that we want to be able to subscribe and do rewrite operations on this table. The next part of the file is the definition for the two functions. The first one is the Dynamo function, which is subscribed to the DynamoDB table, and so it's notified whenever a record gets updated, inserted, deleted. And the second function is the one that is hooked up to the API gateway. And here we define multiple REST API endpoints. One is for creating new bookmarks. One is for retrieving information about the bookmark using the shortened URL, getting a list of all the bookmarks available, deleting an entry, so effectively CRUD operations. And then we have some additional endpoints like preview, getting the types that have been indexed, the categories basically, and as well as generating a redirect that we can follow. The method name that is underneath each of these REST API endpoints is actually a C# method that gets wired up to this API gateway endpoint. So the LambdaSharp tool takes care of all of that for you when you build the module. So let's take a look at the API functions implementation. So it's typical C# code. We derive from a Lambda API Gateway function, and that takes care of effectively wiring it to all the metadata that is in the LambdaSharp module. We have a little bit of initialization where we read the bookmarks table and we initialize the DynamoDB table abstraction with a client and the table name. Now for the adding the bookmark, we went with an approach where we generate a SHA-256 key, base64 encoded, and then just look at how many letters do we need from that string so that we have a unique key. The key is generated by the little code down here. So we see SHA-256. We compute the hash of the URL. We then remove characters that could be problematic when used in a URL. And then we return potential keys, starting with up to 3 characters long to 12 characters long, so effectively 10 keys, by taking the substring of that encoded URL, well, SHA-256, then base64 encoded URL. And the reason we return multiple keys is now we can do a batch operation against DynamoDB table with all the key candidates that we generated. And we only retrieve the ID in the URL. We then execute our batch request, look at which bookmarks we received. If one of them happens to be a document that matches the short URL as well as the full URL, well, then we have a duplicate, and we can just end execution by providing that ID back. Otherwise, we look for the very first key candidate that does not exist, and that's our new ID. We then store this record in the database, setting the new ID in the URL field, and we return that response. Very straightforward. At that point, the record is in DynamoDB, and because the other function, Dynamo function, is subscribed to DynamoDB table, it gets invoked automatically in the background. So this function is much simpler than the other one because it really just provides a single operation. It is invoked with a DynamoDB event, which contains potentially multiple records, and it then executes an asynchronous task concurrently if there are multiple, where it uses the Open Graph Net API library to fetch that page and then extract from it the metadata. And so once we have that, we augment the record weight in the database by setting the title, description, and so on fields so they can be saved back. And then we put it back into our DynamoDB table, and we're done here. So let's take a look at a little bit the other functionality we have. We have the get bookmark, which takes an ID. Now, as you can see, this ID is a parameter in the method, and this gets filled in automatically by the base class from this path parameter. So that's taken care of automatically. If it is missing, it will also cause an error. So you can be sure that this is not an empty value. Then we go and attempt to fetch this record from the database. If we receive null, we throw abort not found, which gives automatically 404 response. I had to think about it. If it was a 400, that's a 404. If not, we initialize our get bookmark response payload, which then is serialized to JSON automatically. So this is kind of how the mechanics of it works. Very straightforward. The last thing I think I just wanted to touch on, and then I'm going to show a demo of the implementation running, is the preview. So again, we get the ID from the request, we retrieve the record from the DynamoDB table, and then we generate the HTML that we use for the preview. So pretty straightforward. Again, it has a little local function helper in case these fields are null, so they don't get added to the response. And because we don't want to return a JSON object, we have to use API Gateway Proxy Response. This gives us the opportunity to change the content type and then set the response to any contents we like to respond with. Okay, so this should be up and running, and I'm using Postman here. So here's a request to have a new link being added to the bookmarks. So let's submit that. The first time there's a cold start, so it might take a few seconds, and we get back a response with a new identifier. We can ask also to, let's say, list the bookmarks. So if we send this, we should see that this one is now in the database. And as you can see, the title, the description, image URL, they're all null at this point because the record got inserted in the DynamoDB table, which then triggered the other Lambda function, which has to now, of course, warm up and do its job. Once warmed up, the operation is very fast. But first time on cold start, it can take a couple of seconds. So let's submit this again just to see if we get the metadata now. Yep, and here we go. Meta has been inserted by the DynamoDB function. And so now if we go to preview bookmark, we can submit that. I set up Postman automatically to always use the last ID that was created and automatically insert that variable. And here we go. This is our response that was generated by the preview REST endpoint, fetching the data from the DynamoDB table. So a pretty straightforward CRUD service. You can actually find the complete solution implementation on my GitHub repo under Bookmarker. Also feel out to reach out on any of these channels, either on Twitter or via GitHub, submitting issues or recommendations. And other than that, I hope you found it interesting. Don't hesitate to leave some comments, recommendations, or challenges you'd like to see us tackle in the future. Thanks.